My name is Roger and I'm from Liechtenstein.
My name is Anatoly, I'm from Kiev, Ukraine.
I'm Larissa from Germany.
My name is Muhammad Ali and I'm from Egypt.
Marina, I'm from Italy.
I'm Tommaso Marchesi and I come from Italy.
My name is Sarah, I come from Iran.
My name is Pietro and I come from Italy.
Hi, my name is Pamela, 28 years old and from Peru.
I'm Shivam, 24 years old, traveled all the way from India.
My name is Denise, I'm an electrical engineer.
I'm Panos, I'm from Greece.
My name is Katerina, I'm 26, I'm from Ukraine.
My name is Bernard, I'm a physicist originally from Austria.
I'm Yazisyan, I'm from Iran.
Good afternoon, everybody, or good evening and good morning if you are connected from countries with different local times. We know that together maybe we can have an international audience. And welcome to this event, which is dedicated to BORGES, an international training program within the Marie Skłodowska Curie action of the European Union, that is coordinated by Professor Carlo Augusto Bortolotti of the University of Modena and Reggio Emilia. My name is Marcello Pinti. I'm professor of pathology in this university, and I'm part of BORGES project. And today I will have you to know BORGES, which is a joint effort of 7 different European countries, different companies, research center, university, joined together in an effort to grow up the new generation of innovators in the field of organic electronics. An effort that will help hopefully European Union to build up the knowledge-based economy, which will be which will be the future of the European Union. Today we will discover what BORGES is, the aims of its project, and how an international training program of the European Union works, and we will also have the opportunity to see some experiments that are performed in the framework of this project. But on top of that, research is made up by researchers, and today we will meet the early stage researcher that has been recruited in the BORGES project. They come from all over the world, and since I am part of BORGES project, I already met her many times, and I can anticipate you that they are very nice and very smart guys, and they are so nice, they are so smart. They beyond their research activity, they've been also able to prepare this nice animation video that will explain you and introduce you to BORGES. So let's watch this first animation video prepared by our early stage researchers.
Imagine a domestic test which is fast, easy to use, and reliable for detection of diseases. Our consortium BORGES works towards making this goal a reality. Want to know more about us? BORGES stands for Biosensing with Organic Electronics. It is founded by Horizon 2020 Marie Skłodowska Curie European Training Network, aiming to train the next generation of researchers in organic bioelectronics for social and economic benefit.
What are you working on in BORGES?
We are working on organic biosensors, portable devices for home testing.
What is an organic biosensor?
An organic biosensor is a device for the detection of chemical substances in a biological fluid like blood. A drop of sample is given to the sensing unit to gain information about chemical substances present. In BORGES, we concentrate on certain type of organic electronic biosensors like OECT, EcoFit, or GFIT for detection.
Interesting. But who is involved in BORGES consortium?
We are 12 beneficiaries and 1 partner in 7 countries across Europe, working together to tackle the multidisciplinary aspects of this project.
And what about the researchers?
15 early-stage researchers of 11 nationalities with different backgrounds are teaming up to reach one common goal. Our backgrounds in engineering, chemistry, biology, pharmacy, and physics ensure to overcome the expected challenges in developing a novel organic biosensor. Thanks for watching. Check out our website.
So now we met the guys and we know a little bit more what BORGES is, but I think it's now the time to meet them face to face and to introduce them to you. And we will start with Panos.
Hello, everyone.
Hi, Panos. And Panos is from Greece. He's one of our 15 early stage researchers. So, Panos, we talk about early stage researcher. What is exactly an early stage researcher within the MSCA-ITN or ETN program of the European Union?
A nice question, Marcello. I'm Panos. I'm from Greece. I have a physicist background. And from all of us, the ESRs in BORGES project, we would like to welcome you in our researchers night. An ESR is practically an early stage researcher. Let's say an undergraduate and postgraduate student in his master's or his PhD, embarking into science or research. And we know that research is funded from universities, is funded from industries or institutes throughout the world, all over the world. But especially in the European Union, there are special actions like Marie Skłodowska Curie action that really facilitates research and innovation. Of course, the whole program is dedicated to the legacy and the contribution of Marie Curie to science and research in general. This is an European training network, an innovating training network, indicating that Europe invests a lot on training and introducing young researchers, young educated people into the world of innovation. And innovation really comes, at least from my experience, when people from different, from multicultural backgrounds, from multidisciplinary fields come together, they collaborate, they exchange their perspectives on the same problem, and they come up with nice solutions just because of the diversity in their educational and cultural background. And this is the thing, that innovation is that different experience are key enablers for innovation. And I think my colleagues are going to explain that how they felt inside our network even further.
Yes, thank you, Panos. So you talk about the early stage research, about the MSCA program, but what is the added value of pursuing a PhD within a European research program such as an ITN? We can ask this question to Denise and Sarah, who are also part of this project that you can meet now. Hi, Denise. Hi, Sarah.
Hello.
Hello. Sarah is from Iran, Denise from Canada, if I remember well. So please.
Yes. So I think there are multiple advantages when we talk about a Marie Curie reaction and when you do your PhD in a Marie Curie reaction, when it's compared to the regular PhD. For example, at the beginning of our project, each of us moved to a different country. So we had an opportunity to live in a different culture, but also learn to work in a different work environment. And I think that's a quite unique experience. Also, like Panos said, we have multiple project partners all over Europe. So we have a quite a big international network. And this network helps us with our training. It helps us to collaborate with our colleagues more often. We do work together, we do research together. So I think it's quite important that all of us can work towards the same goal, different scientific backgrounds.
Oh, we have some little problem connection, the last words, but we got the message. Denise, thank you so much. Sarah, okay. Do you want to add something else?
Yeah, of course. I also think that it's very important that among BORGES we have both universities and companies. so we can really direct our research towards what is needed in industry. And also, I agree with Dennis. We have several events and workshops. Each one of them are hosted by different countries, and that really gives you a great opportunity to meet new people, work in a different place, and try to really adapt yourself to a new environment, which is really valuable also for your future career.
So thank you very much, Sarah and Denise. I think this gives really an idea, people listening at home, of what means moving from a place to another. And, this program gives you guys a great opportunity for your career in the future. But I know that sometimes moving from a place to another could be tough, could be challenging for people. And so this is my impression in general. So was it really difficult to move to a different country and enter a new work, in a new research environment? Larissa, are you there? Maybe you can answer the question. What about the interaction with people from different countries? We met a lot of people from very different places in Iran, from Canada, and so on. You are from Germany, if I remember well.
Yes.
So, yeah.
Well, for me, was one of the most significant advantages of the PhD program that we not only get to know one more country, as we also have like further secondments. And of course, every time moving to a new country, it has unique challenges and interacting with a new team and most likely a new language. But however, I think the integrating process gets easier every time you do it. And like this, it wasn't too hard for me to move to Barcelona, as during my studies, I also lived in different countries. And you ask about interacting with people, and in terms of interacting, like knowing the language of the country you live in helps a lot, but it's not necessary. At university and in an international team, the language is anyway English. So now I see myself really lucky that besides learning a lot on professional basis, I also get to practice Spanish and English daily. And in this way, I think the Marie Curie program gives you a great chance to experience new countries and new work environments and trains you on international level. And this also gives you the opportunity to learn about various backgrounds and about techniques of others and what they are using. So, for example, we also learned about the microfabrication that is Pedro using in Strasbourg.
Yeah.
Good morning from the foggy Strasbourg. Today you will follow me to learn the basics of microfabrication and photolithographic processes. While we walk together to the lab, let me give you a little bit of a background. Lithography comes from the ancient Greek and it literally stands for writing on stones. In the past, our ancestors were using substances such as vegetable oils and animal fat to paint images on rocks. Nowadays, lithographic processes have evolved, and they are at the core of the production of all the electronic devices that you can think of. The fabrication of miniaturized and complex structures is fundamental to produce new and smart sensors with unique features and functionalities. A part of my daily activity is devoted to the microfabrication of platforms that will serve as the base for the development of new biosensors. This is achieved through a particular kind of lithography called photolithography. Before jumping into the action, let me give you a little bit of introduction on what we are going to do in the lab. First, a photosensible polymer, also named photoresist, is deposited on top of a standard silicon substrate. Second, we draw the desired pattern exposing the photoresist to a laser source. The light will change the chemical properties of the exposed area, making it soluble, for example, in a water-based solvent. Third, development. We chemically etch away the exposed photoresist. This process will create a negative of the desired drawing we want to realize. This process shares some fundamental principles with photography. Fourth, evaporation of the metallic contacts and lift-off. We cover the wall substrate with gold and through a process called lift-off, we etch away the unexposed photoresist to finally reveal the final draw. the majority of the steps I described will be performed in a clean room. Clean rooms are closed environments where the amount of dust and particles are kept as low as possible, because any small contaminant can jeopardize the success of microfabrication. The user must avoid smoking and wearing makeup. Before entering the clean room, in order to avoid any external contamination, we have to wear the appropriate protection and follow strictly the protocols. Once in the clean room, the silicon substrates have been washed several times to remove any adsorbate contaminant. Then they have been dried carefully using a nitrogen gun. As a final step of the cleaning protocol, the chips have been treated in a plasma oven. This will make sure that the surface of the chips will be free of any residual organic contaminant. After taking out the samples from the plasma oven, the photoresist has been deposited on top of the substrates. You can clearly see the difference between the coated samples on the left side of the box and the uncoated samples on the right side of the box. Now it starts the fun part. The coated devices have been loaded into the laser writer. This machine will allow us to write with micrometric precision the draw that we created. The samples have been aligned using a camera, and the chosen draw has been loaded. Once the laser is started, it is possible to see through the camera where the machine is irradiating the sample. Here is where the magic happens. After the writing process, the pattern is still not visible, but after immersing the sample in the developer, you can see the draw starting to appear. The exposed area has a different chemical properties, and it can be removed with the right developer, leaving the rest of the sample intact. The samples have been dried, and with the aid of an optical microscope, we carefully checked the final quality of the drawing procedure. The gold has finally been evaporated on the whole surface of the chip, and with the final step, the lift-off, we will remove all the metal in excess, revealing at the end the final drawing. Here there is the final result. We started creating the negative through simple and quick steps of microfabrication, and we ended up with a device ready to be used and tested. We finally came at the conclusion of the clip. Thanks for watching, and stay tuned for other exciting videos.
Thank you for this really nice video that gives us an idea of what you are really actually working, how it works, and also that we also learned that one of the partners is the University of Strasbourg, one of the partners of this European project. And we've seen that, anyway, being a scientist is something funny, exciting, fascinating. Maybe people is not so aware of how it was and how you can pursue this career. So, Caterina and Pamela, that are also part of this network. Why did you decide to go for science? Hi, Pamela. Hi, Caterina. And would you recommend this career to some young students, and why?
Well, as a child, I always was very curious about the world that surrounds us, and as I grew up, I developed a big interest on understanding how the things work and why do they work that way. So, meaning that I wanted to understand like the underlying mechanism and all the interactions that take place, like biological, from a biological point of view, and a chemical, and also the physical point of view. And yeah, all these interactions that take place in order to make something work. And I think that the fact that nowadays we understand and we are actually able to explain different phenomena, like why the sky is blue or how does our body work, is just fascinating. And I think that understanding these very basic concepts is what allows us to develop and to evolve and develop new technology that will actually make our life easier and better. Yet there are many things that to which we do not have an answer. So that's what I like about science. Is it's a continuous learning, and there is something. There's always something new to be discovered.
Well, in my case, also, I have always been fascinated by the world surrounding us. Actually, in the first instance, I wanted to be a marine biologist. I wanted to explore the seas, discover new species, well, everything. Then with time, my focus went more to the biochemistry part, to know, understand, as Katerina said, all the mechanisms underlying how our body works. Why do we get sick or fever? Why do we feel pain? Or what is happening with our body when we do exercise or when we eat chocolate, for instance? And especially because I feel, as many of the other works, of course, that with our work as a scientist, we can contribute somehow with society. So yes, that's one of the main reasons that I decided to go for science. And well, to other people, the young generation, I will say that if you are curious about what is around you, if you like analyzing, if you are always wondering why are things happening in this way, well, my answer is yes, definitely go for science. Actually, science is quite a general word. It could be physics, chemistry, biochemistry, which is what I studied, biology, pharmacy, what Katerina studied, and many others. If you decide to go for science, you will have a wide range of possibilities. And also, it's a very dynamic career. As I said before, I studied biochemistry. But right now, I am here in Modena, working on developing biosensors, which is quite far from what I studied, but at the same time, it is still related to it. Now, I am deepening into my background, but also I am learning new topics and getting new knowledge. And well, this is the beauty of science. It's a fascinating world. And if you are willing to explore it, don't miss the opportunity.
Yes, I'm totally agree with you, Pamela. I think that career in science is an adventure. It's very exciting because you can work on something completely new, something on what no one ever worked before, and yeah, I think that's a huge opportunity, and it stimulates your creativity and I would say also your imagination. And although it can be difficult sometimes and it requires a lot of dedication, at the end of the day, all your effort is definitely worth it.
Yeah, thank you, Caterina, and thank you, Pamela. And for what could be relevant in this case, it's the same opinion that I had many years ago. So the same pathway that I did many years ago. So I completely agree with you. And I think that now we can move much more in detail in this project, in particular, in BORGES project. And I will ask Roger, what are the strengths of this research program, in your opinion?
Yeah, hi everyone. Well, working on such a highly interdisciplinary topic like the development of biosensors requires knowledge in many different fields, as we heard just now. This is very challenging, but on the other side, also very rewarding for us as PhD students, because we get the chance to learn many new things and broaden our horizon beyond the field of our expertise. And I think the big strength of this program is then to provide us with an international, but as well an interdisciplinary and an intersectoral network. I think this is a very unique opportunity and goes beyond the traditional academic training settings. As PhD students within this program, we get exposed to both academic and non-academic sectors, meaning universities, research institutes, and companies, and this all through network-wide training activities. This then provides us with research-related, but also transferable competences and fosters the exchange of knowledge. And I think a big strength of this research program is also that we try to tackle the whole development of a biosensor, from fundamental understanding up to demonstration in an end-user significant context. And this helps us then as students to get familiar with basic research on one side, but also with product development and application. And yeah, besides all these great scientific opportunities, I would also like to highlight what has been mentioned already before, that this program actually allows you to travel and explore new countries and cultures. Not just because, as you can see, we are a group of very international PhD students, but also because we get shifted to other members of the network for short research days.
all in all, I think this is a very rich experience, and it provides us in the end with enhanced career perspectives in both worlds, academia and industry. And speaking about industry and application, did you know that the sensors in our project can be manufactured via industrial printing techniques? I think we should have a look on how those techniques work.
Hi, this short video will show you industrial screen and inkjet printing processes. So what is screen printing? Let's get started. This is a screen printer in our lab. So here you can see the ink of white color placed on the top of the screen. First of all, a squeegee will move and fill the screen and then start the printing process. So once the structures have been printed, they can be examined under a microscope and dried in the oven. Okay, but what are the applications of screen printing? It can be used for printing electrochromic displays, for integrated sensor platforms and smart labels. And let's move back to inkjet printing. So what is inkjet printing then? This is a Ceradrop system in our inkjet printing lab. This is a print head filled with a silver nanoparticle ink. These are the droplets ejected from the print head. Okay, now the plastic foil or the substrate is placed on the chalk or table with a vacuum, and now the desired printing structure is imported into the Ceradrop and ready for printing. Droplets which you've seen recently will form the pattern. And finally, a printing process. And here the printed structure can be cured via infrared or photonic sintering. And finally, the printed structure already cured on a plastic foil. Great, then thanks for watching. Bye.
Yes, thank you very much. Thank you for really nice video. And I think now we can move to the next research. I don't know if Mohammed is able to connect. Yes, he's here. Can you hear me, Mohammed? Unfortunately, we can't hear you. Maybe your microphone doesn't work. Sorry, we can't hear you. Okay, maybe we can try to call you back later on. And okay, let's move and meet Shubham, the next member of his. Hi, Shubham. Hi. Shubham is from India, and this is quite tough period for the world because of the pandemic. And the pandemic hit hard just in the middle of our research program, BORGES. So, can you tell us how if the pandemic affect your research or your training experience, and how?
Pandemic for sure has negatively affected my training and research activities. Because of the lockdown, I was not able to access the lab for almost 4 months and was not able to do any experiments. And then the only option left for me, like for everyone else, is to just read research articles and do some data analysis. But as you said, we just started recently our PhD and I was still in my training phase. So I really didn't have much data at that time to really stay productive. So lockdown was not really an easy phase to deal with. And at that time, I realized that since I still have to finish my training and learn how to use different equipments in my lab, then why not I read about how to use them? So the best source is to read manuals in that case, right? So now at that time, I started reading different manuals of the equipment that I was planning to use in my lab. And now when I'm back in the lab, now the restrictions are a bit eased. So I would say that reading manuals at that time is more have been of a head start for me. In fact, it turned out that many questions which I had in my initial training were answered in the manual. And I doubt actually that no one would ever read manual in normal circumstances. But for me at that time, it turned out to be really helpful. So it was one positive to take from the lockdown. And at that time, since there was not other things that I could do, I also with other fellows in our BORGES project, we thought to start a blog. And then we try to start it and where we try to explain our research in simpler words and share experiences. So in the end, every one of us adjusted in a way to deal with this pandemic. And I think that's what all of us are trying to do. And also we are trying to contribute to, in a way, to control this pandemic. In our project, we studying how does this biosensing happen, right? But this is something that not many journal audience is aware of. So let's maybe we talk about how does this biosensing happen. So my colleague Bernard will explain how does this biosensing really looks like. So yeah, I hope that you will find this good.
So this is our biosensor and our fluidic setup, and we can combine these two. So this is what it looks like when our setup is filled up. We have our sensor connected to our fluidic device, also connected to a measurement instrument, which we can see here our graph, how the signal behaves when we measure just in a normal electrolyte. Now when we change from our normal electrolyte to the electrolyte with an analyte, and start pulling it towards the sensor, we see quite a big change in signal, as you can quite clearly see. And this is how we can differentiate between something with our analyte and something without our analyte.
So thank you, Bernard, for this really nice video. It gives us an idea of what you guys are actually doing in the lab, well, maybe quite hard to understand for people that are not deep in the field, but can give us an idea of what your work actually is. And so you're working hard now, but let's talk about the future. Tommaso from Italy to Germany. Hi, Tommaso. So this is a quite challenging, interesting, and I think very interesting program. How do you envision your professional future? How do you see yourself in the next years during this project, after this project?
Well, it's actually a good question. So as a professional vision for the future, I will still see myself in the research, but most likely in industry. So the importance of research at the fundamental stage was already explained, but what is a bit missing is still the importance of research at an industrial level. So if you think about the development of a product like a biosensor, it's important that we are able to make continuous innovation also from the industrial point of view, so that the product is more affordable and for the community, so that multiple people can actually take advantage of that. So I will see myself in the next years working in industry, but still doing even more applied research than now. I'm an engineer, and as an engineer, I would really like to work in the research and development of a company, maybe becoming a group leader, so I can actually coordinate experiments and analysis from different people with together that we are having one purpose. So to prepare this, for example, this biosensor. What is very interesting for me is also being able to follow the life of a certain product from the idea, from the beginning, to the development, optimization, and then the commercialization. To be able to see this product that is then in the market, and possibly a product that could save life. So this will really be the first accomplishment of a life as a researcher and as an engineer. So if you think about what is happening during the pandemic, a biosensor for virus detection is really important. And if you think about a biosensor for testing or for sensing the cancer, for example, it's very important also in the early stage diagnosis of such kind of disease. So all of this can be developed more and more at industrial level, and I would be really like to be part of that. So another interesting example for that could be developed at industrial level is advanced microfluidic devices to test different samples under different conditions. And I think Puya will talk more about that.
Hello everyone, I'm Puya Azizian. Our team worked on a passive capillary microfluidic that released biofluids and electrolytes with the required pre-programmed order for biosensing applications. As you can see in the video playing this below, biofluids and electrolytes are releasing just after each other to reach the detection site. That is possible by using multi-level channels and geometries with different resistances.
Thank you, Puya, for your contribution. You should be also connected right now. Yes, you are here. Hello. Hi, Puya. Hi, Anatoly.
Hi.
And hi. So, do you think that this experience that you are now living will contribute to let your, professional dreams come true in future? And if so, because it's not so granted for free, if so, how?
Yes, I want to be a researcher, a real one, a scientist, but not far from the industrial applications and locked in the academic world. This is an ideal PhD position for me because I do my research in a company that this company doing research for industries. So it connects the academic world that I mean with the industries that applications of my works are in. Also, being a member of a big research team provides me numerous advantages. For example, as an engineer, I have the chance to learn about various disciplines far from my subjects, like biology. During my collaboration, I learn about these things. I wish I can use these fantastic chances to become a leading researcher in my future. Uh, I mentioned learning about different disciplines during my collaborations. I mean, like learning about research, like what Marinas does.
Hi, I'm Marina, and for my PhD project, I tried to develop a sensor for human health monitoring. In particular, I work with biochemical sensor. A biochemical sensor is a device that is able to detect a target molecule and is able to monitor its concentration in time. In my case, I work with sweat sensor since the sweat analysis can be very useful to obtain information about the health status of a person. Besides, I also work with electrophysiological sensor. Electrophysiology allows us to record the ion current that flow through tissue of our body, and this current mirrors the electrical activity of organs or cells. Since we are interested in monitor some current, we need conductive materials. And for that, we can measure these parameters through electrodes that we place on the skin.
In this video, with the help of Laura, I will show you how it's possible to record different electrophysiological parameters. The first thing to do is to prepare the electrodes that will be placed on the skin. Each of them must be connected to its cable, which is then connected to the acquisition system. In this case, these are commercial metal electrodes. For ECG, the recording of the heart electrical activity, the electrodes are placed on the chest. For EEG, to record the brain activity, the electrodes are placed on the forehead. For EDA, which is the electrodermal activity, we can place them on the hand palm. Additionally, we can also use a sensor to monitor the respiration rate. Then we can start the recording while Laura is at rest. From the laptop, you can see the waves corresponding to the different parameters that we are monitoring. From the brain activity waves, we can easily see the spikes corresponding to the blinking of the eyes and the alpha waves. With this setup, we can monitor different parameters in real time and at the same time. And of course, it is possible and necessary for many applications to record also while moving and running too.
In this demonstration, we use silver chloride electrodes. They work very well, but they also have some drawbacks. Indeed, as you can see, they are quite bulky and there is an adhesive layer to adhere to the skin, but this can also cause discomfort to the user. Moreover, we must use a gel electrolyte layer between the skin and the electrode to have a good connection, which means to have a good recording. But after a few hours, this gel starts to evaporate and then the recording becomes poorer and poorer. To overcome these drawbacks, we can use organic electronics. Indeed, I can use organic conductive materials instead of metals, and this allows me to have conductive properties while also having some properties that metals don't have. For example, I can use a flexible substrate, for example, textile, to build some smart fabric that can be also integrated in clothes. Or for example, I can coat yarns to make them conductive. Or I can also print on tattoo paper to have a cost-effective temporary electronic tattoo. This technology will allow us to have portable devices that can bring us a huge help in medicine, like in early diagnosis or in chronic disease monitoring.
Thank you again for the work by Marina. I hope, let's see if we have now a possibility to connect with Mohamed. Mohamed,
Hi, yes, I'm
there?
here.
Hope you are.
You hear me now?
Hi, Mohamed. Great. Yeah, I can hear you perfectly.
Yeah, that's great.
And we have seen a lot. Yeah, we have seen a lot of things about the work that is going on in BORGES. And
yeah.
As far as this work, how do you expect that this research could be relevant for the society?
It's definitely relevant to the society and especially the public health of our society. What we're doing here in BORGES, and since there's 100 of reports, and also the World Health Organization, they promote the early stage of a lot of disease like cancer and also recently this COVID virus. Because if we could detect the disease early, we can provide the care at earliest possible stage, and that therefore an important for public health and the strategy in all settings. Also for the COVID, it was clear that the research around the globe, they went through finding a way to detect the virus in order to contain it first, also another route to find a vaccine and medication. So detecting virus and pathogenesis is really related to our public health. And what we're doing here in BORGES is trying to find a good way of detecting pathogenesis, accurate way, a quick way as well, and the price is affordable for our community. And that's what we're doing here. In my work, I'm specialized in nanocharacterization at high frequency, at gigahertz, which enables us to understand how the binding of this pathogenesis to the surface and what's happening at the interfaces. So this work is integrated in BORGES to provide the community and the society with a sensor, a biosensor, which is reliable and useful for our public health.
So thank you, Mohamed. Thank you for your words. And I want to also thank you, all the guys who participate in this event that gave us an idea of how important is this kind of research made up of people from many different disciplines that gather together to find a way to solve problems that can go from a very basic scientific problem to a final application that can be useful for society, for industry, for our economy, to make this world a better place. I want to thank you guys once again. I want to thank all the guys that was not present here, Chiara and Carlo, who is the coordinator of the project, was present live, but are the backbones of this work, of this really tough effort we are doing now. And I hope that this has give the sparkle to somebody that was listening or watching this video to decide to go for science in the future and become the new scientists of the new Europe. Thank you again for watching, and see you next time.